Okay, this is part 4 of lesson 6, and we'll proceed where we left off. And if you remember how to convert from binary to decimal, this will be, you put 1 on top here, 2 on top here, 4 on top here, and 8 on top here. So converting this number would be 0 times 1, 0 times 2, 0 times 4, 1 times 8, and we add all of them. So this will be 8. And this will be, again, we'll put those numbers. So 1 times 1 is 1, plus 2, plus 4, plus 8. That's going to be 15. So in decimal it's 15, but we need hex. So 8 remains 8 in hex. I'll write a small h here. But 15 is going to be F, if you remember the hex. Because after F came the 10 of hexadecimal, so 15 is F. So this number here, this long number of binary, could be represented as hexadecimal 8F. Now, to convert from hexadecimal to decimal, we use a similar method as the method that we used from binary to decimal, but now we use 16 as the base. So for example, if the number is 8F, we write on top of the digits, the first one is always 1, and the next one is the base times the previous one, so the base is 16, so the second one will be 16. So we have to multiply 8 times 16 and F times 1, and this will give us the value in decimal. But how do we multiply F times 1? We convert F to decimal, because we only know how to calculate in decimal. So F is 15, 15 times 1 is 15, plus 8 times 16. 8 times 16 is 128, if I'm not mistaken. So if we add those two numbers, we shall get 143. So 143 in decimal is equivalent to 8F in hex. And what I claim is that the number in binary that we have above, 1 0 0 0 1 1 1 1 in binary, if you convert it to decimal according to the method that you know already, right? Putting 1 here, 2 here above, 4, etc., and then multiplying this times this, plus this times this, plus this times this, you already know this method, I claim that you will get exactly the same number. And you can do that as an exercise. Try to convert this binary number into decimal. And if you do get 143, that means the method that I showed you here worked. And what was the method? In order to convert a long number in binary into decimal, we can first convert it into hexadecimal easily by dividing the digits from right to left into groups of 4, because every group of 4 binary digits, my claim is, turns into one hexadecimal digit. And this makes sense because the base 2, which is binary, to the power of 4 gives us 16. So this is the connection between binary and hexadecimal. And later on we'll see how hexadecimal is very useful to represent characters and values that we put into variables. But for right now, just concentrate on the hexadecimal and the conversion. Let's do another short example before I leave you with the homework, and then you can do one on your own. Let's say we have the number 42 in hexadecimal, H, and we want to convert it into decimal. So as I said, the method is to start putting above 1, and then the next one is going to be 16, which is the base. If there was another digit here, then we would put 16 times 16, which is 256. But this is already long calculation, so I will not do it now, but I will give you something as a homework with 3 digits. So for right now, let's just concentrate on 42. So 2 times 1 is 2, and 4 times 16 is 64, and therefore the value of 42 hexadecimal is going to be 66 decimal. You notice that the numbers in hex look smaller than when we convert it to decimal, and that's normal because hexadecimal has more digits, so we can represent higher numbers with smaller values, because the 42 of hex means 4 times the digit that represents the tens or the 16s, and 2 is the digit that represents ones. And with decimal, if we had a number like this, the first one would represent 1 and the second one would represent 10 only. So since 16 is greater than 10, this number in hex is higher than the equivalent number if we had 42 in decimal, for example. So your homework would be to convert the number 730A in hexadecimal, this is a valid number in hexadecimal, to decimal. Okay, I'll give you a hint. A, remember, that was the value 10 in decimal. So when you do your calculation, you multiply, instead of multiplying A, which we don't know what it is, we actually do, because A represents 10. So whatever you put up here will be times 10, and then, as I told you before, the next one will be 16, and next one will be 256, and you'll do the calculation. This is 1, and for the fun of it, I'll give you one more. 1, 1, 1 in hexa, convert into decimal. And I'll probably do another part of lesson 4 in which we'll wrap up decimal and hex, and we'll do the conversion the other way around from decimal to hex, which is very similar to the way we do it with binary. And then we'll start talking about variables, programming language, control flow, and a few other interesting things before we start doing our first program. So this is it for right now.